Greetings, welcome back. Today we're going to talk about process safety performance indicators, and we're going to specifically apply them to cryogenic gas processing facilities. You clicked on it, so let's go. Why do PSPI matter in cryogenic facilities? Well, the big reason is that we're involving high-risk inventories, that we have flammable gases, we know that, and they're under high pressure in some parts of the process. But what makes the cryogenic process different is the extreme cold and some of the hazards that come along with that extreme cold, like the ability to make metal brittle and fracture, the ability to cause frostbite, the ability to form vapor clouds that hang around the ground instead of become buoyant and lift up off the ground. All right. So the other thing is that they can escalate rapidly into fires, explosions, and potentially toxic releases. And the thing about PSPIs is they can give us early detection of weaknesses in our safety systems. And our big aim is to prevent major accidents before they occur. All right. So what are PSPIs? There's two types. First, there's leading indicators. Leading indicators are pre-failure conditions, and they exist before the incident occurs. So we're going to look at leading indicators and lagging indicators. The lagging indicators are after the incident happens, and we want to figure out how to prevent it from happening again. All right, these come out of API RP 754, and we're going to try and stay as close to that as we can, and the Center for Chemical Process Safety guidance. Now, when you're dealing with cryogenic processes, just realize that RP 754 and some industry brochures you might have seen that discuss PSPIs are really tailored toward chemical manufacturing facilities. Chemical manufacturing facilities tend to use high temperature and pressure and not so much cryogenic. They will potentially have some cryogenic processes, but when we're dealing with cryogenic gas processing, that's our big concern. There's a little bit of a difference, and that's why this presentation focuses on the cryogenic. All right, so what is the core framework for PSPI? It's going to have 4 tiers of indicators, like we mentioned, the 2 classes. Tier 1 are going to be major incidents, loss of primary containment, fires, explosions. Tier 2, minor process incidents. Tier 3, near misses. Now you see the first 2 are where actually something has happened. Tier 3 and Tier 4, nothing has happened yet, but we have a condition that could lead to it. So heightened risk for exposure. So that's the difference between Tier 1 and 2 versus Tier 3 and 4. Each tier supports proactive safety cultures. All right. So what about cryogenic plants? What is different there? Well, loss of primary containment from cryogenic service piping and vessels can be a key PSPI. Overdue or failed inspections on vacuum insulated lines and storage tanks. Pressure safety valve testing on cold service relief valves. Ice buildup on frost-related mechanical failures or valves, rotating equipment. MOC process, management of change for changes to insulation, instrumentation, or defrost systems. And then your maintenance backlog specific to the cryogenic temperature zones. Let me talk a little bit about an example of an incident that I was involved with back when I worked with a company that had some LNG processes. We had a system where we had an LNG tank, 3 million gallons of LNG, and there was a 2-inch relief valve outside of the tank on the discharge line between the discharge valve and the discharge check valve. And what happened was liquid got caught in that line and it started to build up pressure and it relieved through the 2-inch relief valve. When it did that, it started to spray into the subdike area. Well, what happened was that 2-inch relief valve stayed open. It froze open and the liquid just continued to pour out of this 3 million gallon tank into the subdike and started to fill it up. The internal tank valve that was the isolation valve was a foot valve in the tank, and it had come down on its seat on a bolt left over from construction, and it couldn't close. So we had 3 million gallons of liquid LNG trying to get out of a 2-inch relief valve, and it wouldn't stop. Our operators put on turnout gear and SCBAs, which were freezing. The regulators on their hips were freezing in the environment of the LNG vapor cloud. Their rubber boots were freezing as they walked into the pool of LNG. One of the men carried a rain shield, just a piece of tin over their head to keep the LNG from spraying on each of them. While this was going on, the LNG was spraying on the tank, on the outer tank. So the LNG tank in downtown Baltimore had a 3-foot thick insulation barrier of perlite, and the outer tank, the outer wall, was being impinged by this LNG, and it caused it to crack. And then you had outside air starting to get inside the perlite and warm up the inner tank, causing the boil off to increase, making the pressure even higher. We had an emergency situation. We couldn't just let it slowly boil away. It was going to be there for a long time. It was creating a vapor cloud along the ground that doesn't really rise until it gets warm, and it's a long way from ignition sources before it does that. So we had the potential for an ignition. Well, these two men were in there. The second man had a steam lance, and his job was to warm up that relief valve. In the post-incident interview, we asked them why they did that. They said that it had always worked in the past. That told us that this is something that was an ongoing problem that they weren't tracking or following or looking for a resolution to. So this day was doomed to happen. Nobody got hurt. The fire department was called. They were too afraid to come in and help. They basically waved at everybody and left the site, gave us a violation for not pulling a pull box outside the plant instead of calling them on the phone. The tank was eventually drained to a 6 million gallon tank, or pumped over to a 6 million gallon tank, and that's what stopped this emergency from becoming something worse in downtown Baltimore. All right, so let's talk about leading indicator examples. You can track your overdue safety instrumented system tests. You can track the percentage of operating permit audits completed. You can look at the number of unresolved management of change documents that are older than 90 days. If these MOCs are out there just languishing and hanging on, then that's an indicator that something's wrong, that you haven't analyzed your process. We can look at the percentage of missed operator rounds. If your operators aren't walking in the plant, then something's going to happen. How about emergency drill participation? Is everybody working in the drills? Is everybody coming out to participate? Are they getting excuses and passes not to come out? All right, now let's look at lagging indicators, the number of Tier 1 and Tier 2 loss of primary containment events. All right, if you actually lost some containment, then that's an indicator that something went wrong. Primary safety valve failures to open at a set pressure. Well, of course, it's a failure if it doesn't open. That's different than if it fails to close, but both can be an issue. Fires and explosions, because these kind of things were going to happen. So if they've happened, then it's a lagging indicator. That's just your way of figuring out if it's leading or lagging. Is it a prediction or is it a recollection? Emergency shutdowns triggered by real faults. If you've had to have an emergency shutdown, that's a lagging indicator. Process excursions outside safe limits. Even if you don't have a loss of primary containment or a fire and explosion, if you challenged your systems, if you went outside of your safe limits, then that's a lagging indicator, something that has happened. All right, so how do we develop our PSPIs in a cryogenic facility? You can use a bow tie or a layer of protection analysis to map the hazard pathways. Here's a layer of protection analysis infographic. It shows you that you've got your potential hazard on the left, and you can have an initiating event, and then you've got independent layers of protection. And once you go through all of your independent layers, if you've got your independent layer intact, then the risk is acceptable. If you don't have all that, then you're going to have the consequences. A bow tie analysis is where you've got the hazard, you've got the things that can go wrong on the left, and then what that means on the right. All right. You want to identify the critical barriers, all those layers of protection. Is it a design? Is it alarms, operator response, procedures? And then you want to tie your indicators to the barriers. You want to make sure that your PSPIs align with your real world protection in your facility. You want to validate them with real incident history. What has happened in your plant before? Look at your audits. What have they uncovered? Get some cross-functional input. Try to get the engineering, the operations, the mechanics, everybody talking together to talk about their own perspectives. You want to target 6 to 8 good high-value indicators and want to review them monthly. You don't want to have 20 indicators that come from a brochure from some insurance broker out there. All right? Now, integrating the PSPIs in your daily operations. You want to embed these PSPIs, tracking them in shift reports and in dashboards. You want to use your KPIs in morning meetings, key performance indicators. You include your process safety performance indicators reviews in monthly safety committee meetings. And then you want to trend them. Are we getting better? That's every month you're looking at them. Are we getting worse? Is something about to happen? Have we paid enough attention to our safety systems? And that's going to change our maintenance and operations. All right. Now, to find out if you're ready for a PSPI audit, you want to ask, do we have a written PSPI policy, and is it tied to our health and safety and environmental mission statement? Are indicators linked to the actual site hazards? Again, if this is a cryogenic facility, are we focusing on the cryogenic hazards as well as the fire and other toxics if we have it? What about PSPIs reviewed? Are they updated every year? Is there visible leadership engagement? So we want to see management paying attention to the PSPIs. And if there's a trending of the PSPIs getting worse, we want them to start asking and pushing buttons. Are near misses and unsafe conditions reported, right? If the operators aren't reporting the near misses and the unsafe conditions because nothing happens when they do, they're going to stop reporting them. And that's an indicator right there that if you're not hearing about it, that there's something out there that you should go look for. I love that deluge system. It's pretty smart. All right, what are the benefits of a robust PSPI program? It's early warning of latent system failures. What's latent mean? Latent means that it's there, it just hasn't happened yet, and it's about to bite you. So we can get an early warning of something that we're not quite aware of before it gets us. Better incident prevention and response. So it doesn't only help us keep it from happening, it also helps us respond better to them. And it demonstrates our commitment to risk management. And that's important to the world, and it's important to our regulators, our licensors, and to our insurance companies. It's going to improve the underwriter confidence and give us a better risk ranking. All right. So PSPIs are not just metrics, they're safety management tools. The adoption reflects the site's maturity in managing major accident hazards. The next step, start small, focus on critical systems, and build from there. All right, I'd like you to subscribe to my Energy Risk Engineering. It's YouTube's hottest energy risk engineering channel. Follow me on LinkedIn. Check out my website at energyriskclaims.com and ask questions in the comments.